Hello everyone, welcome back. This is Mr. Osama Sapi. In this video, we'll be discussing implicit differentiation. Alright, so before we begin, don't forget to like and subscribe to the channel. Alright, let's get started. So, when do we apply implicit differentiation? So, when a function is not given in an easy way, say it's not in the form of f of x being equal to ax to the n. If it's not in this form, we use implicit differentiation. So be mindful, if you've been given a function that is not in this form, sometimes, because we know f of x is y, so if it's not in this form, that's when we use implicit differentiation. Alright, what are the steps to implicit differentiation? So all we have to do is simple. Differentiate both sides with respect to x, but the moment you differentiate a y term, add dy over dx. Remember, differentiate both sides with respect to x, but when you differentiate the y term, add dy over dx. After that, the only remaining is for you to solve for what? Dy over dx. Okay, let's understand this with a few examples. Say we have examples that are saying differentiate with respect to x. I'll start with a very simple example. Say we have an equation that has been given in the form of 2x squared, sorry, let me use cubed, 2x cubed being equal to 2y squared plus 5. So all you have to do is to differentiate each term with respect to x. So what I like to do is simple. I like to collect data and let each term equal to a variable that represents its derivative. So I'll start with 2x cubed. So I will let, for instance, I will let p equal to the first term, which is 2x what? Cubed. And I'll differentiate it. So this will be p prime being equal to what? 6x what? Squared. That is us applying what? The power rule. That's for the first term. The second term, I'll do the same. I will let the second term be equivalent to some variable, say q. So let q equal to 2y squared. Now, if you differentiate this with the power, you know q prime will be what? 4y. Now, the moment you differentiate a y term, remember to add dy over what? Dx. Then lastly, we have the constant 5. So let say r equal to what? 5. And r prime is what? 0. So now all we'll do is this. We'll say p prime in brackets, p prime is equal to what? Q prime in brackets plus what? R prime. So now this is p prime. P prime is simply 6x squared being equal to q prime, which is 4y times dy over dx plus 0. Then we solve for dy over dx. So this is 6x squared being equal to 4y times dy over what? Dx. So now this is the same as someone writing as 4y times dy over dx being equal to 6x what? Squared. If we factorize, we'll have dy over dx. Then we'll have 4y being equal to 6x squared. We can divide both sides by 4y, even this side by 4y. This cancels with that. And we'll have dy over dx being equal to 6x squared over 4y. Now this is basically the final answer, but we can reduce. We know that 2 there is what? 3, and 2 there is what? 2. Therefore, we say dy over dx is equal to 3x squared over 2y. And this is our final answer. Let's look at example number 2. You can pause the video and attempt to do it on your own. Say you have x squared plus y squared being equal to what? 36. Collect data and let each term equal to a variable that we want. So I'll let p equal to my first term, which is x squared. So I say p prime will now be what? 2x. I'll let q equal to y squared. And q prime is going to be 2y, remember, times 2y over what? Dx. Then I'll let r be equal to my constant 36. And r prime is what? 0. Now, if I put this back, it implies that I'll be having something as p prime in brackets plus q prime in brackets being equal to r prime in brackets. So after that, if I substitute, p prime is simply 2x plus q prime, which is 2y times dy over dx being equal to r prime, which is 0. Now, folding it out, you have 2x plus 2y times dy over dx being equal to what? 0. You solve for dy over dx, which means you make it a separate formula, making it as the only thing on one side of the equation. So the 2x can go the other side, and you have 2y times dy over what? Dx being equal to negative 2 what? X. To solve for dy over dx, all you have to do is to do what? Factorize, or you can just divide here by saying over what? 2y, even this side over what? 2y. So this 2y can cancel out with that 2y, and you remain with dy over dx being equal to negative 2x over what? 2y. Basically, you can reduce this to there, 1, 2 there, 1. Therefore, dy over what? Dx is equal to negative x over what? Y. Now, most people get confused about the negative. Should the negative be on top or at the bottom? To be honest with you, the negative can either be on top or at the bottom or even in the middle. The fact is, if you only have one negative either on top or at the bottom, your answer will still come out negative. But if you have two negatives on top and at the bottom, they can cancel out and you end up with a positive. So it doesn't really matter. So this is where our final answer actually ends. Alright, let's look at question 3. Say you have something like sin x minus x squared y plus y being equal to what? 10x. So remember, all I have to do is to collect data. But you can still try this question on your own by pausing the video and then trying to compare with what I have done. So I will let some variables, I like p, so I'll say p should equal to sin what? X. So p prime is equal to the derivative of sin x, which is what? Cos x. Then I'll do the same, look for the next term, and I'll say let q be equal to the next term. So I will not consider the negative, which is here. I will just get the values the way they are. So I have x squared y. Now if you look at this, x squared y is in a product form. So this is product rule. So now what are we going to do when we have product rule? So whenever we have a product rule, remember what we do is this. We know that q prime will be simply a prime b plus b prime what? A. So you can do a data up here and say, what is the value of a? The value of a is x squared. Now what's the value of a prime? A prime is to what? X. What's the value of b? B is simply just y. What of b prime? The derivative of y will be 1, but since you have to add dy over dx, we'll just say it's dy over what? Dx. If we substitute for this, we end up having q prime being equal to, remember, a prime b, so a prime is 2x, b is y, plus b prime, which is dy over dx, b prime a, and a is what? X squared. So q prime is equal to 2xy plus x squared dy over what? Dx. 2xy plus x squared times dy over what? Dx. So that's for x squared y. So I'll do up another data for r. So I can say let r on this side where there's space equal to what? Y. Now say r prime is equal to what? Derivative of y is 1, but since we have to add dy over dx, be 1 times dy over dx, which is just dy over what? Dx. Then I can also let some other letter like s be equal to what? 10x. Now say s prime is now just what? 10. Now this implies that you're having p prime minus q prime plus y is represented by r plus r prime being equal to what? S prime. Then you can substitute. P prime is simply just cos x minus q prime. Q prime is 2xy plus x squared dy dx plus r prime, which is just dy over dx being equal to s prime, which is just what? 10. Now, if you follow it out, you'll be having something like cos x minus 2xy minus x squared dy over what? Dx plus dy over what? Dx being equal to what? 10. Now, at this point, all we need to do is to make dy over dx a subject of what? The formula. So by doing so, we'll have negative x squared dy over dx plus dy over dx being equal to 10. The cos x comes the other side and it's going to be minus cos x. The negative 2xy goes the other side and it's going to be plus 2 what? Xy. Now basically we just have to factorize this. So if I pull out dy over what? Dx, if I pull out dy over dx, I'll be having negative x squared plus what? 1 being equal to 10 minus cos x plus what? 2xy. Then I can divide both sides by negative x squared plus 1. Then this side, negative x squared plus 1. So this cancels with that. And you just have your final answer as dy over dx being equal. Now remember, you on top you're having 10 minus cos x plus 2x what? Y. Over the bottom, which is minus x squared plus what? 1. Now minus x squared plus 1, you can simply just push negative inside and end up having something like 1 minus what? X squared. And basically this would be your final answer. Alright. This is very good. Let's try and do another question, which is going to be question what? 4. So all you can do is to pause the video and attempt to do this on your own. So having something like x squared plus what? Y squared minus 4x plus 5y minus 8 being equal to what? 0. So we don't really have to show data on this one because I think we've gotten the hang of it, unless otherwise. So let's try to do this one without showing data. Alright, so differentiate x squared. We're going to get to what? X. Differentiate y squared. We're going to get 2y times what? Dy over what? Dx. Differentiate y minus 4x. You get minus 4. Differentiate plus 5y. You get plus 5 dy over what? Dx. Differentiate minus 8. That's 0. Differentiate 0. You know it's a 0. So you end up having 2x plus 2y times dy over what? Dx minus 4 plus 5 dy over what? Dx being equal to what? 0. After that, make dy over dx a subject of formula, which you have 2y times dy over dx plus 5 dy over what? Dx being equal to all those things not having y, but not having dy over dx to go the other side. So I'll start with the minus 4. The minus 4 go on the other side, and you have a plus 4, and the plus 2x go the other side, and you have a minus what? 2x, like that. So if you factorize dy over dx out of the expression that you're having, you have 2y plus what? 5. This is equal to 4 minus what? 2x. You can divide both sides by what you factored out, which is 2y plus 5. Even the other side, you can do a 2y plus what? 5. So this cancels with that. Therefore, the final answer, which is dy over dx, is equal to what? 4 over what? 2x. A lot of this is over 2y plus what? 5. Alright, let's have a go with it. Alright, so now let's try something that is a bit tedious, but very interesting. The last example. So let's try this example. Say we have y cubed minus x sine y plus y squared over x being equal to what? 8. Alright, you can pause the video and attempt to do this on your own. Let's start with our data. So if we collect data, we can say, okay, I'll let p equal to my first term, which is y what? Cubed. P prime is going to be equal to what? 3y squared times dy over what? Dx. Then I also let the next term, I'll let p equal to what? Remember, don't consider the negative, just get what you have. I get x sine what? Y. Basically, this is the power rule. So I'll do p prime being equal to a prime b plus what? B prime what? A. Then I'll collect data and look for a. A is going to be equal to what? X. A prime is going to be equal to what? 1. Then b is going to be equal to what? Sine y. Then b prime is going to be what? Cos y. Remember, dy over what? dx. If we plug this back, p prime is equal to a prime b. So it's going to be 1 times sine y, which will just be sine y, plus b prime a, which will be cos that times x. So it's going to be x cos y dy out of what? Dx. So you have that. Now, we also have the next term, which is having y squared over what? X. We can also do a data up for it. So let's just say let s be equal to what? Y squared over what? X. Now, to do this, it's a quotient rule. So remember, it's going to be a prime b minus b prime a over what? B squared. Isn't it? Alright, so what we'll do is simple. Let me just do that so I can create more space. Okay, so let's do a data up for a. So a is going to be equal to y squared. So a prime is simply equal to 2y dy over dx. Then do up for b. B is simply x, so b prime is equal to what? 1. If you plug this back here in s, so you have s prime being equal to what? It's going to be 2y dy over dx times x minus 1 times y what? Squared. The whole lot of this is over what? X squared. Simplify furthermore, s prime is equal to, it's going to be now 2xy dy over what? Dx minus y squared over what? X squared. So that's your answer here. So we have this one, and we also have for p prime and q what? Prime. Take note of everything. Now we know that even if I had said let r be equal to 8, r prime will be what? 0. So we have now differentiated each term in that statement. So if we now put it in the statement, or we plug them back, what we'll have is this. Write it here. We'll have the first one, we had 3 y squared dy over dx minus sine y plus x cos what? Y dy over what? Dx plus, we also had 2xy dy over dx minus y squared over what? X squared. And this is equal to what? 0. Now to simplify clearly, we can just multiply the entire thing by what? X squared. So that we can end up having things that are simplified. So we have 3x squared y squared dy over what? Dx minus sine, no, let me say x squared sine y minus x cubed cos y dy over what? Dx plus 2xy dy over what? Dx minus y squared being equal to what? 0. Then all we have to do now is make divide with the x out of the formula. So we just have 3x squared y squared dy over dx. We also pull x cubed cos y dy over dx plus, you can also get 2xy dy over dx, and the other things you can take them this side. So the y, negative y, because the other side becomes positive y squared. Okay, we can also get the x squared sine y, which is negative. If it comes inside, it's going to be positive. So x squared sine what? Y. So from here, we have to do is to factorize. So you can do dy over dx. If we pull out that, we'll be having x squared y squared minus x cubed cos y plus 2x what? Y being equal to y squared plus x squared sine what? Y. Divide both sides. Divide both sides, we're having 3x squared y squared minus x cubed cos y plus 2xy. This is also over 3x squared y squared minus x cubed cos y plus 2x what? Y. This cancels with that. You get yourself to y over dx being equal to y squared plus x squared sine what? Y over 3x squared y squared minus x cubed cos y plus 2x what? Y. So that's a derivative. All right, so implicit differentiation is very interesting and quite involving, but it's really interesting, trust me. So all you have to do is to be going through these questions and examples that I've actually given in this video. Go through them over and over again, and you get a hang of it. And make sure you also watch the videos that I've made on power rule, quotient rule, product rule, logs, the ln, the Euros number, and all those things that are needed. My name is Mr. Hussein Wasapi. Don't forget to like and subscribe. I strategize before you become a statistic. I just want to get that A plus.